Hey friends, welcome to Flight Test. I'm Josh. Today we're going to show you how to take a simple, common, large pizza box and turn it into a flying wing. Now if you haven't seen the release video yet, please check it out in the links below. We love repurposing common materials to make them take flight. Let's go ahead and get our materials in order. As always, we have free downloadable plans, and you can also support us by going to the store and getting a power pack to fly this. Let's get started. What you're going to need to build your pizza box flying wing is a power system. This one's already soldered, but if you need help soldering, check out the links below. We have plenty of videos to help you out. We're going to need 2 micro servos, a pizza box, preferably empty, a downloadable template. I've converted it to foam board to make it a little bit bigger and easier to trace, a pop bottle cap, a razor blade, a steel ruler, some tape, and hot glue. First, let's flatten out the pizza box. Use a pen to trace the template with the score cut facing up. Cut along the trace with a razor, using a ruler as a guide if you wish. Now go ahead and pop out the wing, but make sure you save the scraps because we're going to use pieces of the box for future parts of the wing. Use the template to mark the locations of the score cut on the pizza box. Now line up the marks with a ruler and make a light crease with your thumbnail. For the spar, cut out the top section of the pizza box. Fold it in half and measure 5/8 of an inch from the top. Remove the excess. Bend the spar in half. Fold over 1/2 of the wing surface so the back edge of the elevon lines up with the trailing edge of the lower surface. Now while you have that folded over, mark between the second to last and the last crease on the top surface of the wing, on the bottom surface of the wing, so you can mark the location for your spars. Draw a line between the marks. Measure the distance from the bottom and transfer it to the other side. Take the spar and widen the ends so the airfoil tapers to about 1/2 of an inch. Glue down one side of the spar. Now let's repeat that on the other side. So now we're going to fold over both halves of the wing top surface. We're going to look at the center and trim as necessary to make sure we have a nice snug fit in the center section. Fold the wings over and make a crease where the elevons will go. Go ahead and place a small bead of glue on each crease of the wing top surface. This is going to give us extra rigidity and support and also hold our wing shape. Glue the leading edge, the top of the spar, and the trailing edge, and fold the wing over on its edge and allow the elevons to bend down over the table. Hold this for about 45 seconds. Bend the elevon back and forth so there's little resistance in its deflection. Let's repeat the wing assembly on the other side. For the center section, lay a bead of glue loosely on the top and smear it off with a piece of scrap cardboard. Put a piece of tape over the center section, ensuring a tight fit and a strong joint. Select this servo arm here and remove 3 sides, leaving the longer side for our push rod. Take a moment to center your servos with the servo centering tool if you have one. Cut out a spot for the servo so that it's centered as possible over the elevon. In this case, it's roughly 4 inches from the center of the wing. Use a pair of pliers to remove any spar material that you may cut through to allow the servo to fully seat down. Test fit the servo with the arm favoring to the outside of the wing. Now cut a slot for the control horn so that it lines up with the servo arm and the holes are over the elevon crease. Insert the push rod to the topmost hole of the control horn. Mark and bend the push rod so the elevon has an 1/8 inch to 1/4 inch deflection. It's going to be roughly 12 degrees. Make sure your servo wire is going towards the center of the wing so we can access it later. And glue the servo in place. Glue down the control horn on all 4 sides, top and bottom of the elevon. Now repeat this process on the other side of the wing. Now we're going to cut an access hatch on the bottom of the wing using the perforated edge of the pizza box as a hinge. Drill holes in your bottle cap corresponding to the template provided for your motor. Attach the motor with the shortest screws possible, making sure that your screws do not touch the winding of the motors or else it will damage the motor. Cut out relief slots on the wing for the motor mount, making sure that the motor is as square and centered as possible to the wing. Now glue the pop cap onto the wing, making sure that you put glue on all 4 sides of the joint, but avoid the motor. Now we're going to access the servo wires and plug it into the elevator and aileron ports of the receiver. Plug in your battery to make sure that everything is moving properly and determine which direction your motor is spinning. Now install your prop with the proper rotation and make sure it produces thrust when it's turned on, either clockwise or counterclockwise. We're going to go ahead and put our receiver and our ESC inside the wing into the hatch and tape it down. Put a strip of Velcro for optimum battery placement and also for proper CG. Use the template provided to trace out the wingtips. Make sure that your wing edge is flat, so when you glue the wingtip on, it is perpendicular to the wing. Once the wingtips are dry, you're ready to fly. All right, so we have our little pizza box wing ready to take it to the maiden. You always want to make sure you launch into the wind, probably about 3/4 throttle with this one at a slight degree angle up. We got a little bit of wind today, but she flies great. Friends, I want to thank you for watching. As always, thanks for being part of the Flite Test family as well. Make sure you download your free downloadable plans if you guys want to build this. All the links for the electronics you need are down below. And also, if you haven't checked it out yet, check out our FT stem. Everything we use to take on problems to make things fly, we use the engineering design model, the exact same stuff that we teach kids from K through 12. Check out the links below. We'll see you next time.